Good afternoon, everybody. My name is Henno Morkel. I work for Optron as the UAV segment specialist. So today I'm going to talk to you a bit about LiDAR on multi-rotor systems. So let's get into it. My title is A Geo-Odyssey of UAS LiDAR Mapping. So UAS-based LiDAR mapping has taken off in the recent years quite a lot, with a big buzz and a big interest, especially because it's cheaper than traditional large format aerial LiDAR surveys. You are obviously limited in terms of area coverage. Okay, so some abbreviations, so excuse me for some people that already might know these, but for those that don't, just to go through them quickly. So UAS, Unmanned Aerial Systems. LiDAR stands for Light Detection and Ranging. UAV, Unmanned Aerial Vehicle. RTK is survey method of real-time kinematic. PPK is also a survey method of post-processing kinematic. DG is a new surveying georeferencing method of direct georeferencing, which I will get into a bit later. And then EO, which stands for external orientation of a drone. So again, a lot of you might already know what LiDAR is in 3D laser scanning, but for those who don't, so just a quick explanation. LiDAR is basically 3D laser scanning surveying method that measures the target, that measures the distance from a target by illuminating it with a laser pulse, exactly like this one that I have over here. So it just measures the distance, but it does it for millions of points to give you accurate topography of an area. So there's three main types of laser scanning: airborne, mobile, and terrestrial. So if you look in terms of UAS market, as I said, it's a booming industry. It's one of those things that, you know, everything that gets smaller is of interest. So here are some of the key players in terms of LiDAR sensors for UAVs. So here on the left-hand side, we've got the microdrones. So microdrones is a company based in Germany that develop integrated solutions for multi-rotor UAVs. Optron also recently signed up as a reseller for microdrones. You can see they've used a SICK industrial laser scanner inside of this completely integrated laser scanning system. Then many of you would be familiar with the Regal line of laser scanners, with the Regal Vux UAV, the Regal Mini UAV over there. Then there's also the Yellow Scan French company of UAS LiDAR systems, and also a popular one is the Velodyne LiDAR, which brought out the Puck laser scanner that you see over there. So if we look broadly at the goal, what is the goal of UAV laser scanning? So the goal would be to capture elevation and geographic data for final accurate mapping product, to generate the most accurate digital terrain models and other 3D models that represents the Earth's surface and features. And this also entails to be able to capture ground terrain data that lies underneath foliage and tree canopies and vegetation, and also then to capture accurate elevation data over a larger area quickly and efficiently. So if we look at some of the current methods that there's obviously airborne LiDAR, which is with a manned aircraft. There's airborne photogrammetry, also with manned aircraft. There's satellite imagery, which resolution is also getting better and better each year. Then there's airborne photogrammetry via UAVs and airborne LiDAR via UAVs. So already most of you will know what photogrammetry hopefully is. So photogrammetry is basically determining a 3D point cloud via stereo pairing with multiple images. So a very popular software package out there is called Pix4D. As you can see in this picture here, the image below is a 3D point cloud. Each point there, you can see all the rays are aerial triangulated from each image that was taken by a drone. The limitation of this is obviously that what you see is what you get on the photo. So it generates a digital surface model instead of a digital terrain model. So you will not get the terrain underneath the tree canopy or other vegetation. So again, some other limitations: time consuming in terms of putting out a lot of ground control points to achieve survey-grade accuracy. Also, as just mentioned, it's the limitation of a digital surface model versus a digital terrain model. If you have to have accurate terrain for drainage models and the works. Also, in terms of power lines, you won't pick up power lines with photographs, but you would with a LiDAR scanner. And you also need a lot of image overlap to get dense data set. If we look at RTK UAV surveying, so real-time kinematic, just to briefly touch on that. It's a surveying method to achieve high accuracy with a real-time kinematic with a GPS system. So if you look on the left here, you'll see a normal surveying method of a base station with a surveyor and his rover, and it communicates with satellites that he basically walks around and he collects GPS points. Now with RTK surveying in terms of drones, it's the same principle, except that your drone now becomes your rover. So each time it takes a picture, it's taking that position and you have your base as well connected. Then if we go and look at the new technology that's out there, called direct georeferencing, it's the ever-increasing need to be more accurate and more efficient. So the accuracy of UAV captured data is directly related to the positional accuracy of the UAV while it is capturing data. So direct georeferencing, and in terms of the microdrone range, it's a Trimble-powered board. That's basically a GNSS, high-precision GNSS, and inertial sensor. Now, with the aid of this, you not only have GPS, but you also have inertial motion. So you have your sensor angles, and I'll go into that a bit more. So what is the difference between RTK and PPK versus direct georeferencing? As I said, instead of just having with RTK and PPK, getting your northern, easting, and elevation positional accuracy, you are now getting in traditional terms, the omega, phi, and kappa values, the angles of the exterior orientation of the actual drone while it took that photo or while it shot out that laser pulse. This also, in more plain terms, means that you basically directly georeference that picture within your accuracy, your 1 or 2 centimeter accuracy, as it's taking the picture in there. So just a quick video to explain on the microdrone LiDAR side of things.
Photogrammetry has some limitations, one of which is extracting elevations, particularly when you have tree foliage or any vegetation of any shape or form. In photogrammetry, what you see is what you get. While LiDAR, the signals penetrate the foliage and it gives you the bare earth model.
We wanted to add a LiDAR product range.
The MD Mapper LiDAR is a new product to provide the mapping industry with fully integrated LiDAR product. We are the only vendor around the world that provides a direct georeferencing technology. Georeferencing implies that we tie an image that just happened to be captured up in the air to its actual location on the ground.
The goal is to reconstruct a terrain model of the area that you have now. We worked with several sensor manufacturers and select the best to design the best family of products.
The best sensors, when integrated properly, we end up with a credible mapping product. So direct georeferencing technology has opened a new field altogether for the mapping industry, allowed for flying over inaccessible areas, corridors of utilities, infrastructure, pipelines, and so on and so forth. At the end, we have the perfect solution for every application out there from the LiDAR.
All right, so I think that gives a good overview of what the LiDAR system on a UAV is about. Also, that Dr. Mohammed Mustafa, a highly distinguished scientist at Microdrones, argues that traditional RTK and PPK systems have inherent problems when it comes to accuracy, that they sacrifice accuracy and quality for speed. He also points out that the relative position of a UAV can be determined more accurately by relying on the UAS IMU, so the inertial measurement unit, coupled with the GPS versus the traditional RTK GPS method. So then again, with the advent of direct georeferencing technology, with the LiDAR payload, surveyors and geospatial professionals can capture data and process it in a fraction of the time versus traditional aerial triangulation methods. So here on the left you can see the Trimble Planix board. This is the APX15 that's coupled inside of the LiDAR system. So just some of the most common applications of UAV LiDAR. So there's obviously corridor mapping. That's the biggest one, I would say, for roads, railways, pipelines, electrical transmission lines. Then for mine surveying, volumetric stockpile calculations, coastal mapping via erosion. That's quite a good one as well. And forestry, deforestation, getting the exact topography below forest canopies. Then on the MD LiDAR 1000 product, it's just a quick video as well. The workflow.
Our MD LiDAR 1000 product is a completely integrated package that includes a drone, payload, a group of softwares, and a dedicated workflow.
A lot of service providers throughout the world are looking for a service quality LiDAR that is small and lightweight enough to be carried by a nice drone like our MD41000. So we basically created a complete ready-to-go turnkey solution for our customers. From the beginning to mission planning until the end to exporting your LAS files, it's a very complete and ready-to-go solution.
Microdrone's MD LiDAR 1000 is field tested, it's field proven. It doesn't call in sick no matter what the weather. Wind, cold, heat, moisture, it's ready when you are.
The planning component is actually done using MD cockpit software.
So basically what I'm going to do is just going to draw the zone that I want to survey, and we're going to start up the drone. And we can see now it's starting the scanning process, and the drone is actually doing its mission. So once we landed, we got to retrieve the information, take the data, and start post-processing work.
The georeferencing, the automated point cloud processing, all of that is done in a seamless, fully integrated workflow.
So here we have the farm building. You can see some vegetation. So here we have the point cloud of the farm building in the 2D view.
Without the board set calibration, you will see some misalignment between the two strips. And if you look at the after, you will see that those two lines now are one line after we did the bore side calibration. You calibrate your system properly, you end up with consistent and repeatably accurate mapping product.
What we're trying to do is make that whole process a lot easier from that beginning state of collecting the data all the way to processing it, analyzing it, and presenting it to whoever's going to use that information. This is the whole part of what microdrones focus on for our solutions, is to make that whole process as easy as possible.
Right, so if we go and just have a quick look at the advantages of the direct georeferencing. So as I previously mentioned, it is you basically create a GPS and an inertial system to calculate the external orientation angles of your sensor as well, instead of just the GPS positions when it took the data. So if you combine them, you can see you have all inertial and GPS advantages in motion alignment, so versus just using GPS or inertial only. If you look at RTK and PPK versus direct georeferencing, so with RTK, PPK, you only get half of the external orientation, so that's just the position. If you look at DG, you get the full orientation with 6 degrees of a view with the IMU. Yes, so you don't need ground control points with the DG, but for surveyors, obviously, always you'll have some ground control points to check your data is actually where it should be. Right, then in conclusion, the UAS LiDAR industry has seen a huge advancements in the past 4 years in terms of accuracy and longer flight times. I personally believe that photogrammetry are not obsolete and that it still has its rightful place in the aerial surveying and mapping industry. But the advent of a DG coupled with LiDAR technology will open many doors in the UAV industry going forward. So yes, another important notice, keep your calendars open. So we as Optron are going to have a MD LiDAR 1000 demonstration, planning it for sometime in June. Please come and have a chat with us at our stand number 14 here in the Dome if you're interested, and I can get your contact details and all that. And there we are. Thank you very much for listening to me, and safe flying.